Alright guys, so welcome, and this is from Fundamentals of Engineering Mathematics problem which we are going through in this video. This is basics of math which might show up in your FE exam of whatever trade, because mathematics is going to be same for all the engineering backgrounds. So let's get into this question and try to solve it and how to solve it. What is the length of a line segment with a slope of 4 by 3 measured from the y-axis to a point 64? So now here, when you look at the questions, it is clear from the question that you have been given a slope which is m 4 by 3, and you have given 2 points which is x1, y1 is 6, 4. As you can see, 6, 4, x1, y1 is given, and slope 4 by 3 is given. Now looking at this question, it is very much clear that it's a basic point slope formula question. So here that you can start from equation of line. The formula would be y minus y1 is equal to slope x minus x1. This is the equation which will be used to find out the value of y, and from there we can find out the length of the line segment. So what we're going to do next is just plug in those values from the questions we have, right? So this would be y minus y1 is 4, slope is 4 by 3, and we have x minus x1 is 6, right? So the next step would be y minus 4. When you open this bracket, it would be 4 by 3 into x, right? And this would be 3 in 6, so 3 2s are 6, and 4 and 2 would be 8. So this is the equation, and then when you carry forward the 4 into 8, this would come out to be y is equal to 4 by 3x minus negative 8 plus negative 8, and when it goes this side it would be positive 4, so it's going to leave us with negative 4. So this is the equation which will be used to find out the value for y. Now look at this diagram here. If you read the question properly, this is the x-axis and this is the y-axis. Now we are given a slope, right? The slope is given as 4 by 3, right? Now here, what will be the value of y on the x-axis? What will be the value of x on the y-axis, right? Because we have to find the length of the line segment with the slope measured from the y-axis. So the value of x at the y-axis would be 0. So when you plug in, so here we can write on the y-axis, sorry for the camera, on the y-axis we have x is equal to 0. So therefore when we plug it in, y is equal to 4 by 3, 0 minus 4, so we're gonna get the value of y is equal to negative 4, right? So we're gonna get this equation. We got the value of y. Now so we got two axes, which is we got x2 is equal to 0 and y2 is equal to negative 4. So now in order to find the length of a line segment, we have a formula here which is d is equal to under root of x2 minus x1 square plus y2 minus y1 square, right? Now x2, which we got from here, don't mess up the signs, just follow the values you got. That would be 0 minus x1, which we already had it from the question, is 6 squared plus y2 we got -4, and y1 we had it from the question, which is -4. Please make sure of the signs, otherwise your answer will not be accurate. So here you get -6 square plus negative is -8 square. So this is going to be 36 plus 64, which is equal to 100 square root, so which will be equal to 10. So here your answer is 10. So just to recap, the whole question is you had to find out the length of the line segment, right? This is the formula for the length of the line segment, where the slope is given 4/3 as we plotted here in the graph, and which is measured from the y-axis. Since it's measured from the y-axis, we have to take x is equal to 0 to the point 6 and 4. So we are given 2.6 and 4. So what we did is we plot down the equation of line, which is y minus y1 is equal to m multiplied by x minus x1. So we got, when we plotted the values from the question, we got the equation of y. Now we took the x value is 0 on y-axis, since we have to find that point. So we plotted that x is equal to 0, so we got the value of y. After we got the value of y, we found the length of line segment. So now we have two points, x2 y2 and x1 y1. Then you just plot it in this equation, and then you got your answer, which is 10. Pretty straightforward, simple problem. So I think you should expect something like this in the fundamentals of engineering exam.